Hello, my dear students. Today, let us discuss some of the topics under your Module 2. The subject is Elements of Civil Engineering and Mechanics. So, let us discuss what is equilibrium and conditions of equilibrium. Okay. So, what is equilibrium? When a stationary body is subjected to external forces, and if the body remains in the state of rest under the action of forces, then the body is said to be in equilibrium. So, a body is there, that body is subjected with the external forces, and if the body remains in the state of rest under the action of forces, what they are telling, in spite of the applied forces, the body remains in the state of rest, means it is unaltered or undisturbed. Okay, if that is the condition, then the body is said to be in equilibrium. What is the principle of equilibrium? According to this principle, a body is said to be in equilibrium when if the algebraic sum of all the forces acting on the body is 0, and also if the algebraic sum of the moment of forces about any fixed point is 0. Okay, are you understanding? A body is said to be in equilibrium means what? The algebraic sum of all the forces, when a body is unaltered or undisturbed, when the algebraic sum of all the forces acting on that body is 0, so that the forces gets nullified and the body remains in the state of rest. And that is the case when a body is in equilibrium. And also if the algebraic sum of the moments, if the forces are not in the plane, then moment will act. So then the algebraic sum of moment should also be equal to 0. Okay, then the body is said to be in equilibrium. Okay, another statement we can add, a body is said to be in equilibrium if there is no translation. Correct? Sigma fx equal to 0, sigma fy is equal to 0, so it is not moving in the x direction or it is not moving in the y direction, and also no rotation, the moment is also not there. If this is the condition under the action of forces, then the body is said to be in equilibrium. Now let us see the conditions of equilibrium for different force system. So coplanar concurrent force system. For this coplanar concurrent force system, what are the condition? That sigma fx equal to 0 and sigma fy is equal to 0. If the system of forces follows this rule, then the system of forces are in equilibrium. If coplanar non-concurrent forces idre, if sigma fx equal to 0, sigma fy equal to 0, sigma m is also equal to 0, then these forces can be tell that the system of forces are in equilibrium and the body is in equilibrium. Okay, if the force system is parallel, then sigma f equal to 0, sigma m is equal to 0. So non-coplanar force system, f equal to 0 and fy is equal to 0 and fz, in three coordinates it should be 0 and moment should also be equal to 0. So now let us see what is equilibrant. Equilibrant, what do you mean by equilibrant? Sometimes the resultant force system is not equal to 0 when the body is subjected to some forces. Okay, and the algebraic sum of the forces are not equal to 0, then there is a force, okay, which is the called as resultant, which makes the body to disturb or which makes the body to move. In that case, okay, the body is not in equilibrium. Okay, in that case the body is not in equilibrium. The force which is required, so in that case when it is disturbed, the force which is required to keep the body in equilibrium is known as equilibrant. Whenever a body is disturbed by the forces and the algebraic sum of the forces is not equal to 0, then the body is not in equilibrium. The force which is required to keep the body in equilibrium, keep the body stable, a force which is opposite to the applied force, if the body generate means it will be in equilibrium. So that force which is opposite to the applied force, the force which is required to keep the body in equilibrium is known as, that force is called as equilibrant. Fine, that single force is called as equilibrant. So now we shall move to the Lamys theorem. This theorem states that if three forces acting at a point are in equilibrium, then each force is directly proportional to the sign of angle between the other two forces. If three forces acting at a point are in equilibrium, then each force, P is a force, R is a force, Q is a force, is directly proportional to the sine of angle between the other two forces. So now let P, Q, R be the forces acting at a point O. Let alpha, beta, gamma be the angles opposite to that force, or they are the angles between R and Q, Q and P, P and R. Fine. Alpha, gamma, beta. Okay. Now how we shall prove that now. So this is the force P. So take for proving this, we should remember our converse of triangular law of forces. What is the converse of triangular laws of force? Tells us if three forces are there, these three forces are taken as the sides of triangle. Then if they are taken as sides of triangle in order, okay, in order, then sine rule, by the sine rule what we can write, P by 180 degree minus alpha, this side by this Q by 180 degree minus beta, then this R by 180 degree minus gamma. By sine rule we can write this property we know. So here take this P, I'll show you now. So this is the force P, so we'll take this P. Okay, so P we took, then there is a force called R, so we have to start from head of P. So this is a force R, this is P, this is R, okay, and Q is downwards. Fine, this is Q. Okay, so this P should be continuous. Okay, so what is this angle? How much angle? ಎಷ್ಟು angle ಆದಮೇಲೆ R ಇದೆ beta. Fine, this is the angle beta. Likewise this R angle, what is this angle? This is, sorry, this is alpha. Sorry, 1 minute. Okay, so P, after the beta value R is there, right? So this is the angle beta. Now R, this is the angle after R. Q is alpha, this is the angle alpha. Okay, this is the force Q. So what is this angle? This is gamma. So see, this is beta, this is alpha, this is gamma. So now we have to find the inner angles for this triangle. We have to find inner angles. So here in the figure you can see, if this is beta, so this full P is 180 degree, so 180 degree minus beta, so this is 180 degree minus beta. Okay, as a straight line, if it is 180 degree, so likewise only. Okay, here the author has written in simplified way. So 180 degree minus beta, inner angles 180 degree minus alpha, 180 degree minus gamma. So by sine rule what we can take, P by sine 180 degree minus alpha, Q by sine 180 degree minus beta, R by sine 180 degree minus gamma. So sine 2 pi minus anything, sine 2 pi minus anything, that it will return the angle only. So P by sine alpha, Q by sine beta, R by sine gamma. So which we have to prove by, which is the Lamys theorem. We got the relation P by sine alpha which is equal to Q by sine beta which is equal to R by sine gamma. Whenever three forces are given and they are coplanar and concurrent, then we can use this relationship for finding the unknown force or to find the unknown angle. Okay, this was about the Lamys theorem. So now we shall see what is free body diagram. So What is free body diagram? So see there in the figure, a free body diagram is a diagram which represents the various forces acting on the body. Okay, this free body diagram is nothing but a sketch shows the various forces acting on the body, keeping in equilibrium by removing the contact surface. By removing this contact surface, we will only retain the forces which are acting on the body, that too in equilibrium. Okay, this is easy. Okay, free body diagram. So see here, this is the figure A. This is spear and it is tied with the rope. Okay, and here is the contact surface. So we can see the, we will take this point. Okay, so this spear has a mass, weight W. Okay, so because of this contact surface we can expect a reaction here. Okay, so this is T, the tension of the rope. So how we shall write the free body diagram? So take this point. Okay, take this point, let assume this is a point. Okay, so weight of this spear which is acting, always the weight will always act in downward direction. This is W. Fine. Then here one reaction R which is opposite to the weight of the mass. This is the reaction given by the contact surface. This is R. Fine. Here we have another force which is due to the tension in the wire. This is T. So two forces at a point. So three forces. So these threes are connected at a point. So these are three forces that they are coplanar concurrent. So now for this type of problems we can apply the Lamys theorem and we can find out T. If the W is given, we can find T and R. If R is given, we can find T and W. Likewise. Okay. Now let us consider another example. So here see. Okay. Same type of example. The spherical ball is there. So here is the contact surface. So reaction will be here. Okay. But weight will be downward only. Okay. W. So here what are taken. So this is the point. So in spite of taking here W, they have taken it up. Here direction is important. In the same line of action, it will be okay. So W, so reaction R is there. R, then T is the tension force, then another force T. So this is the free body diagram for this figure. So this was about the free body diagram. Another example I will show. Before that, define equilibrium. What are the conditions for equilibrium? This may be the possible questions. So define equilibrium. Any system of forces acting on a body is said to be in equilibrium when the resultant force is 0 and the algebraic sum of the forces should be equal to 0. Understood? Same. There, with reference to body we have been talked. Now with reference to the forces, any system of forces acting on a body is said to be in equilibrium when the resultant of all the forces is 0 and the algebraic sum of all the forces should be equal to 0. Here you can add, and also the algebraic moment of all the forces should also be equal to 0. You can add the algebraic sum of moment also. Now a body is said to be in the state of equilibrium when the body should be in the state of rest under the action of forces. So what are the conditions for equilibrium? Sigma h should be the forces in the horizontal direction should be equal to 0. These are the conditions for equilibrium. What? Sigma h equal to 0. All the forces in horizontal direction should be equal to 0. All the forces in vertical direction should be equal to 0. And all the moment equal to 0. There are three conditions for equilibrium. Sigma h equal to 0. Sigma v equal to 0. Sigma m equal to 0. In some textbook, sigma fx equal to 0. Sigma fy equal to 0. Sigma m equal to 0. So these are the three conditions. If that satisfies, then the system of forces are in equilibrium. Okay, so here principle of equilibrium for different force system. Okay, this is okay, that is important, but you will understand that. Okay, while we solve the problem, you'll understand. Now define the free body diagram. See here, this is the sphere, and it is contact surface is here. So weight of the sphere and contact surface is there, so opposite to that we can get expect a reaction. So this is the free body diagram for this diagram. Here you see sphere is there, weight of the sphere will be there, and that will be in this direction. Okay, then r1 reaction will be there, contact surface, then r2 reaction will be there. So this is the free body diagram for this. Now suppose only sphere is there and you don't have any contact surface, then tension T will be there, with that weight of the sphere will be there. So this is the free body diagram. Here you can see for this type of system of forces. Strings, cable, wire are always subjected to tension only. The forces act outwards. Okay, spheres are subjected to inward reaction. So just note down this point so that while solving the problem it will help us. Now we shall solve the first problem, easy one. Okay, as I discussed earlier, a sphere is touching to the wall of weight 100 kilonewton. This is a sphere which is touching the wall of weight 100 kilonewton. The sphere is touching to the wall of weight 100 kilonewton. Sphere is touching to the wall and its weight is 100 kilonewton. Find the tension in the wire. So here we have to find the tension in the wire which is hung to the wall. So we can see here is one contact surfaces. Okay, so first what we should do, we should write the free body diagram. How? So take this point. Okay, now so weight will be there, the weight is 100 kilonewton. So either you take weight here, weight is 100 kilonewton. Okay, then reaction will be there at the contact surfaces. So this is the reaction R, fine. Then T, so this is the T. So this is the free body diagram. Okay, this is clumsy, so we can also write this, write like this, that is we can bring the weight here. Okay, we can shift this reaction to, you can shift but the direction shouldn't change. So it is coming left to right means left to right only, up to down means up to down only, and we can here we can denote T. Okay, so see here, neglect this. Okay, weight R, T, this is the free body diagram. So this is 30 degree, right? So this is 30 degree. So by the alternate angles this is also 30 degree. If we take here one line, okay, 30 degree, here also 30 degree due to the property of alternate angles. Okay, so see, you take W as F1, take R2, R as F2 and T as F3. So now using Lamys theorem, what? So weight W as F1, W divided by sine alpha, right? W divided by F1 by sine alpha, F2 by sine beta, F3 by sine gamma is the relationship according to the Lamys theorem. This is the relationship. Now consider F1 as W. So F1 is 100 by sine alpha. What is the angle? Alpha is the angle between the other two forces. In between the other two forces, what is the angle? This is the angle. Okay. So this is 90 degree. This is 30 degree. 90 plus 30, 120 degree. So 100 divided by sine 120 degree. Next, R, the force R divided by sine beta. So what it will be? R divided by, so already 30 has gone from 90. 90 minus 30 is 60. So 60 plus 90 is 150. So R divided by sine 150, and that is equal to F3 is T. T by sine 90. So T by sine 90. The force opposite angle, this force opposite angle, this T force opposite angle we have to take. Now by this relation, this is equal to this is equal to this. So consider any two, 100 by sine 120 which is equal to T by sine 90. So we can find T is equal to 100 by sine 120. Why? Sine 90 is 1. So T we can calculate, that is 115.47 kilonewton. So once we got T, substitute in any of the two equations to find this R. So R is equal to 100 sine 150 by 100 sine 150 by, here you see 100 sine 150 by sine 120. So R is equal to 57.73 kilonewton. So this was the simplest problem to understand the importance of the Lamys theorem. So for this type of problems, when there are three forces and they are coplanar and concurrent, we can use this relationship and we can find the unknowns T and R. We can also find by equations of equilibrium, that is sigma fx equal to 0, sigma fy equal to 0. We will get the solution. By both the way we can find the solution. So now let us see another problem. Okay, figure shows the lamp is fixed with a string. Determine the tension in the string. So B is the lamp. Okay, it is fixed with the string. So there are two string A and B. So let this be T1 and let this be T2, and weight of the lamp B which is acting downward, let this be the 15 kilonewton. How does the free body diagram? So take a point now. So weight is acting downward. So weight W, then another force is here. So T2 and T1. So this is the free body diagram. T1, this is T2, this is W. So in between angle we have to find out by the properties of quadrants, right? So see here T2. So it is here 45 degree. So if we take quadrant at this, okay, now since it is 45 degree, by alternate angle this is also, by the properties of alternate angle, this is also 45 degree. Okay, now this is 60 degree, so this is also 60 degree. Fine. Okay, now there are three forces and they are coplanar and concurrent. Can we use Lamys theorem? Yes. So what is F1 by sine alpha, F2 by sine beta, F3 by sine gamma? So take anyone as F1. So take F1 as 15 Newton, which is weight. So 15 Newton weight divided by what is the force? So here, so this is the W and we have to, this is W. Okay, we have to calculate between here, as this is 45. So this is 90. So 90 minus 45 is 45. 45 plus 60 is 105. So opposite to the force W, the angle is 105. So F1 by 105, which is equal to T2. So T2 divided by, so this is 60. 90 minus 60 is 30. So 30 plus 90, it is sine 120 degree. So the force in the opposite to full angle ತಗೋಬೇಕು. Next T1. So T1 opposite angle is, this is 45 plus 90, 135. Fine. So F1 by sine 105, T2 by sine 120, T1 by sine 135. Now take any two equations. So F1 we know 15. 15 by sine 105 is 0.96 is equal to T1 by sine 135. So cross multiply. So T1 is equal to 15 sine 135 by sine 105. So T1 is equal to 10.98 Newton. Similarly, T2 is equal to F1 into sine 120. We have to cross multiply here. F1 by sine 120 divided by sine 105 will get 13.44 Newton. So we have three relations there. So equate 2 by 2 to get two unknowns. Fine. This was about the equilibrium chapter, and for by using the Lamys theorem, I hope you understand. Thank you.